this HPC space, if we are going to design applications that are going to take advantage of this new sort of technology, we also have to consider how we're going to tailor our applications to do that. So if you could say a little bit there, that would be helpful.
Absolutely. So the question is related to latency, critical, and what's some of the impact of the application. How would they need to be perhaps more morphed into these new architectures. So first, with regards to latency, in fact, the latency gains, the latency improvements here are potentially very, very good. There is almost no latency in terms of this conversion. Going from the electrical plane to the optical plane, almost no latency there. The latency comes in so optical by its nature is a circuit switch technology. It's not a packet switch technology. So when you set up a circuit, you set up this optical light path between point A or multiple points. It takes a certain amount of time to set that up. It's related to the speed of the switch and other things which you can optimize, but you don't actually need to, because the changing traffic pattern, communication pattern of these applications is not very fast. And so my kind of proposal here is that I set up the network, I set up the connectivity that I need, and prior to the running or between the jobs that I'm running. And that connectivity just, it doesn't change. You still have all-to-all, you still have your packet switches, the small messages still get, and even if they're very uniformly distributed, everybody goes to the right place. It's not the old architecture where I have to split the elephant flows and the mice, none of that decisions. No added decisions. And so it just gives you more bandwidth to the large flows or to two endpoints that are communicating with each other a lot. And in fact, the latency, and we've shown some of that in our analysis and also in our experiments, is actually improved, because you don't have to go through these electronic packet hops. You have a much more direct. I've taken out the initial setup latency of the switch, so just to be sure that that's clear. But once I've done that, I go run it, and it's not only is there no added penalty on the latency, it can actually be improvement. Now, there's nothing I can do about C, the speed of light. So at some point you get far distance, and so there's a time of flight latency that we're not going to be able to do anything about with this technology. But, and then with regards to the applications, yeah, there may be some. The whole goal here is to try to be as minimally invasive as possible. So externally, the software, the operating system, etc., is the same. And then there's an advantage if you want to, tailor your application. Meaning, if kind of the key story is that if you know as much about your communication pattern of the application ahead of time, we can optimize for that very easily with this technology. That's where the design might be. I hope that answers.
Thanks for the great talk. Also, the chip industry is working in that field. I'm missing some names on your last slide. Can you compare your work a little to what is done in the chip industry?
Absolutely. The good news is that many companies are investing and working in this area. I'm sure I can't even begin to name all. But for example, some of the larger vendors, such as Intel, such as IBM, HPE is the only things you see here are the people that I personally have projects with and work with. And so, let me just pick on Intel, because why not? We all pick on Intel, for example. So they have a silicon photonic efforts in and of itself. Their approach is, right now, it's basically to address the data center market as far as, this is what's available externally to the public, so I don't know any internal things. So externally to the public, they're addressing the data center market, they're working, and so they're developing these kind of DCIs, these data center to data center interconnects, which you may hear those. It's like 400G, maybe, with PAM4 and with, other coherent modulation, things like that. This is not what I'm talking about here, because all those things are kind of anti-energy efficiency designs. There's extreme signal processing. I mean, they serve a purpose. Obviously, there's a market for them, but what I'm talking about here is specifically for HPC, high-performance data centers, and kind of the shorter distance interconnects. And so the optimization that we do is for much, much more bandwidth density. That's what we care about. It's not about the longer haul and higher data rates. It's the bandwidth density.